What is going on YouTube? This is your boy Network Prodigy, and what I got for you guys today is an educational video. I'm going to be showcasing you guys a feature inside of BGP that you may not even be aware of. I actually didn't become aware of this feature until I started doing my CCIE studies, so I'm going to show you guys this feature today. Now, if we can get to 200 likes, what I'll do is I'll make another educational video showing you guys another cool feature in BGP. Now, the feature that I'm going to showcase you guys in that video, it's a feature that we use when we're doing BGP over DMVPN, if you're familiar with dynamic multi-point VPN tunnels. So let's get to 200 likes, guys, so I can do that video for you guys. And as always, if you haven't already, be sure to subscribe to my channel. That way you never miss out on anything that I release. Now, the feature that I want to talk to you guys today about is a feature called BGP Active / Passive. And like I said, this is a feature that a lot of people probably don't even know exists. So let me kind of explain to you guys how it works, and then I'll show it to you live at the CLI. So one thing we know about BGP is that it uses TCP, and the well-known port for BGP is TCP port 179. So we know that BGP uses TCP. Now, just like any other application, when you're running BGP, the first thing you're going to do is you're going to attempt to form the three-way handshake. This is going to be the very first thing that you do. So here is how it typically happens. On any TCP session, you're typically going to have two sides. You're going to have side A over here, and you're going to have B over here. So it's always going to be two sides. This side over here is what we're going to call the active side. And then this side over here, we're going to call the passive side. And here's how it works. If you're familiar with active and passive and LACP, it works the same exact way almost. So the active side, when he wants to form a three-way handshake, he's going to send what we call the send request. So the active side is always going to be the one to start the three-way handshake. He's the one that's initiating all of this. So he's going to send a send request over to the other side. This is the passive side. He's not going to be the one to initiate the three-way handshake with the send act. He's waiting for the other side to do it. So when we say passive, he's just kind of sitting back chilling, waiting on the other side. But when this send act arrives to him, he's going to know, okay, the device on the other side wants to do a three-way handshake. Well, let's do it. So he's going to respond with the send act. Now, a lot of this stuff is going to sound familiar to you if you know TCP. But the send act gets sent into the network. It gets back over here to the active side, and then he's going to respond with the act. So this is your three-way handshake. Here's 1, here's 2, and here's 3. And once this is complete, now you can start running whatever application you want to run between the two sides, which in our example is BGP. Now here's the thing. The active side, I'm going to put this in a different color, is always going to be what we call the TCP client. He's going to be the one always initiating the three-way handshake with the send request. The passive side is always going to be the TCP server. He's never going to be the one to initiate the three-way handshake, but if the other side does, he will agree to the three-way handshake by responding with the send act. Then of course, the client side or the active side then responds with the act. So this process is going to happen even with BGP, because we know BGP uses TCP. Now here's the cool feature about BGP. BGP will allow you to choose or control what side you want to be the client and what side you want to be the server. So let me just kind of get rid of everything. And let's just say we got router 1 and we got router 2. and they're connected to each other, and we want to run BGP. Well, we know there's going to be some type of TCP connection between 1 and 2. Somebody has to be the TCP client. Somebody has to be the TCP server. Well, there's a feature in BGP that allows you to control this. So if you have some requirement where router 1 has to be the client and router 2 has to be the server, well, you can do that with BGP. Now, most of the time, you really truly don't care who's the client and who's the server. See, in most times, in most cases, what's going to happen is when you come on router 1 and you configure him to peer with router 2, router 1 is going to send a send request over to router 2. And the same thing is going to happen on 2. When you configure 2 to peer with 1, router 2 is then going to send a send request over to 1. So both of them are going to initiate the three-way handshake. And then if both of them initiated at the same time, I think it's whoever has the lower router ID becomes the server. So if router 1 knows the higher router ID. So if router 1 has the lower router ID, he becomes the client. And then router 2 is going to become the server. So router 1, he's going to use some high port number like 5000. And router 2, since he's the server, he's going to use the well-known port number of BGP, which is 179. So in the real world scenario, you probably don't care who becomes the client and who becomes the server. But if there's some weird requirement where router 1 has to be the client and router 2 has to be the server, you can control that with BGP, and I'm going to show you that. So you can control it to where router 1 is active, router 2 is passive. So now the only way router 1 and router 2 will become BGP peers and establish the TCP session is router 1 has to send the send request, router 2 never will. So that's what we mean by active and passive when it comes to BGP. Now let me show you this, guys, at the CLI. So let's hop on over to GNS3. You can see I got router 1 and router 2. They are connected. I'm going to come on over to router 1. And first thing I want to do is do a ping over to router 2 just to make sure I got connectivity, and I do. Now to show you this, guys, what I want to do is I want to do a debug IP packet. And what this debug will do is show you every packet entering and leaving the router. So it's a good tool to use when you want to troubleshoot, you want to see what's actually entering and leaving the router. You can do a debug IP packet. Now, I only want to see the BGP traffic. I don't want to see everything. So I'm actually going to create an access list and only capture the BGP traffic. So the way I'm going to do that, I'm going to say IP access list 100 permit. Let me see. Did I spell that right? No, not IP access list. Access list 100 permit TCP any equal to BGP. And then I'm going to say access list 100 permit TCP any equal to BGP any. So what I'm trying to do is capture BGP in both directions. So let me just do a show access list to make sure I got everything right. So here's my access list right here. I got access list 100. The first line is permitting TCP any. So any source, any destination, as long as the destination port is BGP. And then I got permit TCP any as long as the source port is BGP. So it's matching BGP in both directions. Now what I'm going to do is do a debug IP packet. And I want detail and not detail. I'm just going to do debug IP packet 100. And you can see it says IP packet debugging is on for access list 100. So now what I'm going to do is I'm going to do router BGP 100. I'm just going to say router BGP 12 for router 1 and 2. So 12. I'm going to say neighbor 192.168.12.2 is in remote autonomous system 100. Now hopefully our debug picks up everything and we should see packets going out. Okay, and trying to see where it shows us the send packet. It's probably not going to show us there. Let me do a no debug all. Let me do a debug IP packet detail. Maybe it is detail, and then 100. Maybe this will show us the actual send, because I want you guys to see that it's actually sending send requests going out. So, okay, there we go. So let's do a no debug all, no debug all. And what I want you to see is we have a packet that's coming from router 1, because this is router 1's IP address. It's going to router 2, and the source port you can see is some random high port number, and the destination port is 179. So right now, router 1 is trying to start the three-way handshake, and we can see this is a send packet. So router 1 is initiating the request. Now down here, you can see we have a packet coming from router 2. The source port is 179. That's the destination port that router 1 was using. He's doing an ACK, but it's a reset. That's because we haven't configured router 2 yet. So router 1 is trying to do a three-way handshake. Router 2 is saying no because I don't have it configured. Now, what if I don't want router 1 to initiate the connection? Meaning I don't want him to send these send requests. Meaning he's the one that's going to be the server, because it's going to be router 2 that's doing the send request, not 1. Well, I can do that. I can make router 1 act passively. See, right now he's acting actively because he's initiating the three-way handshake. We can tell by the send request. So I'm going to go to global configuration. I'm going to go to router BGP 12, and I'm going to do this command. Neighbor 192.168.12.2. I'm going to do transport connection mode, and you see we got two options, active and passive. Active is the default. You can see it says actively establish the TCP session. That's you sending out those send requests. Passive means passively do it, meaning don't do anything. Wait for the other end to do it. So I'm going to do passive. Okay. Now I'm going to turn my debugging back on. So let's do a debug IP packet detail 100. Let's do a clear IP BGP star. Okay. This means I want to restart everything with BGP. Now, I don't know if you notice anything or not, but you don't see any send messages going out. You don't see anything BGP related happening at all. And that's because right now, router 1 is acting passively. So if I scroll up, when we did debugging IP BGP or debugging IP packet detail 100, we saw the send messages going out. We saw them going out. So we saw where router 1 was initiating the connection. But right now, we don't see anything. And if I do a show debug, I can see I'm debugging IP packet with access list 100. It's just router 1's not doing anything. This is what passive is. So now the only way router 1 and router 2 will become BGP peers, I have to come over to router 2, and I have to configure router 2 to peer with router 1. So neighbor 192.168.12.1 remote-as 12. And hopefully I got it configured right. Let me do a show run. Section BGP. He's actually in the 100, so I need to change that. Router BGP 12. Neighbor. And I got a lot of output. No debug all. All right, let's do router BGP 100 or BGP 12. You can see I'm actually getting a message, neighbor's in the wrong AS. So I got to change that. So no neighbor 192. I'm not going to say no. I'm just going to say neighbor 192.168.12.2 remote autonomous system 12. And what we should see is the peer come up in just a second now that I have him configured in the right autonomous system, which we do. So if I scroll all the way back up, what we're going to see is that we have a send request coming from router 2. coming to router 1. Okay, the source port is some high port number. Destination port is 179. This is the SYN request. Okay, what we should see later is that router 1 is going to send the SYN ACK. So here's an IP packet coming from router 1. The source is 179. The destination is that random port number router 2 was using. And this right now is the SYN ACK. This is your SYN ACK right here. So we got the SYN coming from 2, the SYN ACK coming from 1, and then here we have the acknowledgement. So it's coming from 2, it's going to 1, and it's an ACK. So right now we just configured it to where router 1 will always be the TCP server, because he's never ever going to initiate the TCP connection because he is passive, which means it's always going to be up to router 2 to do it. See, I can come on router 2 and I can do the same thing. Neighbor 192.168.12.1, transport connection mode passive, right? And then if I do a clear IP BGP star, what you're going to see is the neighbor is going to go down, but it's never going to come back up. And if I do a show IP BGP summary, both of them are just going to show that the peer is idle. And the reason why is because both of them right now are passive, and neither one of them is initiating the three-way handshake. And if you don't complete the three-way handshake, then the peer won't come up. So that means one of them has to be active. They can both be active, but one of them has to be active. So that means I have to come over to router 1. I will have to get rid of this command. So no neighbor, I'm just going to say transport connection mode passive. Just going to get rid of that. And when I do that, the peer should now come up, because now router 1 is going to be initiating the connection again. And the peer now comes up. Now, how I can verify that router 1 is now the client because he initiated the connection, I can do a show IP BGP neighbor 192.168.12.1 or 12.2. I can come all the way down, and what I'm looking for is local host and foreign host. Local host is going to be the router that you're on, which is router 1. Look at his local port. It's a high value. So he's using some random port number. This means he's the client. If you look at foreign host, this is the peer, which happens to be router 2. He's using the port of 179. So whoever is using the well-known port number of the application, they are the TCP server, and the other guy is the TCP client. But what I wanted to show you guys is you actually have control over this. So you can control which router you want to be the server and which one you want to be the client. Will you ever do this? Probably not. But if you're like me and you're studying for your CCIE lab exam, they'll probably do some dumb shit and put this on the exam. Like they may give you a question that says, configure BGP between router 1 and router 2 and make sure router 1 is always the client. See, in the lab exam, there's no telling what they'll do. Like there's a troubleshooting section in the lab exam, and let's just say router 1 and router 2, the peer isn't coming up. It can be not coming up because how they stage the topology, both of them are passive, like how we saw. So you make both of them passive, of course the peer is not going to come up because neither one of them is starting the three-way handshake. So that's the feature I wanted to show you guys. It's the BGP active / passive, where you can have a router be active or you can have him be passive depending upon your requirements. Again, you're probably never going to do this, but if you ever have a requirement that you do have to, then BGP does give you that option. So that's what I wanted to show you guys today. Really hope you guys enjoy it. Don't forget, if we get to 200 likes on this video, I'm going to do another video showing you guys another cool feature in BGP. So let's get to 200 likes so I can do that other video for you guys. And as always, don't forget to subscribe to my channel. That way you guys don't miss out on anything. So thank you guys for watching, and I will see you guys next time.